Hello, everyone. This is Robotics and Automation class. This is about forward and inverse kinematics problem. Example 3. Given a three-link manipulator kinematic diagram. So here is the diagram. The question is find L1, L2, L3, theta 1, theta 2, theta 3, and theta h. The angle of the end effector. Okay, before I proceed, let me check if it is on recording. Okay, it's okay. This is what we are going to find. There are seven parameters to solve. So let me copy another graph to put illustration. Okay. So let me copy this one and place it here. Okay, so no space. Okay, this is fine. For a while, for a moment, I will make it a little bit enlarged. Okay, that's it. So what problem is this? This is the question. Since we are looking for the joint angles, so it is obviously it is inverse kinematics. So I will indicate here inverse kinematics. So here, this is the illustration. To find these values, we go one by one. Start with the L1 and theta 1. So here is the solution. Start with the L1. So how we can get the L1? So you look at the diagram. And this is understood that this is the L1. This is our L1. If this is L1, the next link will be L2. And this is L3. Okay. Start with the L1. You need to form a triangle. So that's the triangle here. Form that one. You change the color. And that triangle is a right triangle. So this is a right triangle. So if this is L1, we have this one is the theta 1. From here to here is our x1. And from here to here is our y1. Immediately, you get the values of x1 and y1. Okay, since we are looking for the L1 and theta 1, the formula for L1 will be the square root of for a while. Square root of, that is x1 squared plus y1 squared. So substitute the value. Our x1 is 4. So that's 4 squared plus 9 squared for the y. So we get the value of L1, which is equal to 4 square plus 9 square square root, we get 9.85. No specified units, so simply you write here units. So this is the answer for the L1. After L1, let us solve for the theta 1. So it's simply inverse tangent of y1 over x1. And substitute the values. Inverse tangent, your y1 is 9 over x1, I mean 4. That is 4. Then we got the theta 1. So 9 divided by 4, inverse tangent, that is 66.04 degrees. 66.04 degrees. So that's the answer for the theta 1. This is already solved. Now we are done with the L1 theta 1 from this triangle. Now let's proceed for the L2. To find L2, form a triangle here, or you can form it here. So from here, draw a straight line horizontally. That's it. Just to form the triangle. So this is 90 degrees. And the theta 1, where is the theta 1? I mean theta 2. So you need to project a line extended along L1. So this is the extended line along L1. Okay. So that's it. We need to move a little. Yeah, that's it. And then we can be able to get or define or locate the theta 2. So this is our theta 2. Okay. We cannot get the theta 2 without solving the included angle here, which is the theta 2 prime. After we get theta 2 prime, we will be able to get the value of theta 2. So from here to here will be our, this is our x2. And from here to here will be our y2. So let us solve for the L2. So again, L2 is equal to the square root of x2 square, and add that with the y2 squared. How can we get the x2? So this is the x2. From here to here is x2. Okay, from here to here. So this point has 10. You can put here x2 prime, no problem, because this is x2. You cannot put x2, so x2 prime. This is x2 prime, this point. Okay, I can specify that one. For here, for this point, this is our x2. Now I will change the color. Okay, this is x2 prime and y2 prime, this one. So therefore, x2 prime minus, this is x2 prime minus x2 prime is from this point to the origin minus x1, that is our x2, plus this is our y2 prime minus this is y2 prime, this y2 prime. So y2 prime is from here going down here, that's y2 prime. In order to get y2, is subtract y1 with the y2 prime. So this is correct. This one, let's correct this. y1, this is from here to here is y1 minus from here to here is your y2. So this is from here to here is your y2 prime. Minus y2 prime square. And substitute all the values. We have here our x2 prime is 10 minus the x1, which is 4 square, plus our y1 is 9. Our y2 prime is 5 square. Therefore, we are able to get the L2. So 10 minus 4 square is 6 square plus 9 minus 5 square, which is becoming 4 square equals square root of 52. The answer here is 7.221 units. We got the answer for the L2. This is the L2. Then we get already L2, then we can proceed to the theta 2. Is this one. So as I said, we cannot solve theta 2 without getting first the theta 2 prime, which is the included angle of the link 2, which will be inverse tangent of your y2 divided by x2. So substitute the value, inverse tangent, our y2, this is our y2, this one. This is our y2, this one, which is 9 minus 5, which is 4 divided by 6. 10 minus 4 is 6. Therefore, our theta 2 prime will be equal to, no need, take the value after inverse tangent, 4 divided by 6, inverse tangent, that's 33.69 degrees. 33.69 degrees. So this is the answer for the theta 2 prime. Not the final answer. We will use that one to determine the theta 2. So continue from up here. So let's continue from up here. So I will just draw a borderline. We just draw a borderline down. For a while, let's move that one first. Yes. Go back, go back. Okay, that's it. Stretch this one. Let us going to I need to stretch this one for a while. Okay, that's it. Then let's stretch this one. That's it. Now let me save first. Now carry on. Let's carry on. For a while, it is still saving. Okay, almost done. Now carry on from here. We will be able to get the theta 2. How? So theta 2, we already solved the theta 2 prime. So how can we get the theta 2? Okay, so watch carefully the angles. So since this is theta 2 prime, if we project a horizontal line here, if this is theta 2, we can see also on one side, this one is also, this one is also theta 2 prime. That's theta 2 prime also. So if this is theta 2 prime and this is our theta 1, this is our theta 1. So that's theta 1. Now, obviously, we can be able to determine the theta 2 by adding theta 1 and theta 2 prime. So here, add theta 1. Erase. Let me erase first. Let's add theta 1 plus theta 2 prime. We will get the theta 2. So the value of theta 1 is 66.04 degrees, while theta 2 is degrees, while theta 2 prime is 33.69. So 33.69 degrees. Add all of it, 66.04 plus 33.69, we get 99.73 degrees. So this is the answer for the theta 2. So we are done with the length 2. Okay, let's proceed for the L3. So this is the L3. So how are we going to calculate for the L3? Before that, we need to establish or form a triangle. So here, project a horizontal line here. Horizontal. I will repeat. Delete this one. Project a horizontal line here. And then project also the vertical line here. So insert. Let's insert a vertical line here to form a triangle. You can form like this, or you can form from this side. There's no difference for that. So let me change first the color of the line for a while. This is the change the line. Okay, that's it. Let me let's change that to another color, magenta, and this one another color, magenta. Okay, that's it. And this triangle is this triangle is a right triangle. So it is a right triangle. Then here here, we need to uh, solve for the included angle. So the included angle here is called theta 3 prime. That's theta 3 prime. Okay. And where is the theta 3? For the theta 3, you need to extend the L2. You extend or project a line along L2. So just draw a line, extend it. This is our extended line as the reference angle for the theta 3. So this is our reference line with respect to theta 3. So the theta 3 is is between the reference and the link of L3. So this is the link of L3. Therefore, the theta 3 is from here to here. That's theta 3. Okay. We cannot solve theta 3 without solving the theta 3 prime. So we will solve first the L3 and theta 3 prime. Start with the L3. So again, L3 is equal to square root of x3 squared plus y3 squared. The next thing is how can we determine the x3? Go back to the graph. Look at the graph. Where is the x3? That's the question. So the x3 is here. From here to here is our x3. From here to here up is our y3. So how to get x3? X3 is, this is the x3. From here, which is this point, to the origin 0 is our x. From here, straight downward is our y. The end effector or the position. So if we subtract x, this is from here, from here to here, x. Minus the x2 prime will give you, x2 prime is from here to here, will give you x3. So x, I will write here x. Okay. Subtract that with the x2 prime minus x2 prime square. Okay. How about for the y3? For the y3 is, this is the y3, this one from here to here is y3. We can get y3 by taking y, this is from here to here is y, subtract that with the, from here to here will be your y2 prime. So y minus y2 prime is y3. Y minus y2 prime is y3. So substitute all the values. Our x is 12. That's 12. Minus our x2 prime is 10. It's 0. Then square that one. Then plus, let's go to the y. Let's go to the y. Here. Y3. Y minus y2 prime will give you y3. So that is 7 minus 5. 7 minus 5 square. So finally, we get the L3. This is 2 square plus 2 square is 4 plus 4 becomes 8. So 8 square root, 8 square root will give you 2.83. So this is 2.83 units. This is the answer for L3. 2.83 units. And then we can be able to solve for the theta 3. But you need to solve first the theta 3 prime. So theta 3 prime is inverse tangent y3 over x3. And we know y3 is 2. This is y3. And this is, x3. And this is y3. So 2 over 2 inverse tangent 2 over 2. I think this is 45 degrees. Because equal. 2 divided by 2. Shape tangent. Yes, it's 45 degrees. The answer here is 45 degrees. We got now theta 3 prime. Now, how are we going to get that's the question. How are we going to get the theta 3? So go back again to the graph. So I will just insert a line, extend the line here. Okay, undo. Just insert a line for a while. Okay, that's it. Okay, not. I have to delete this one. Okay, let me continue. So here, we need to know what angle is this. Again, here to here is obviously theta 3. So theta 3 prime. This is theta 3 prime. And how about this one? How about this one? What's the angle of this? The angle of this, since this is extended here, you can see it's the theta 2 prime. It's theta 2 prime. Now, if you add theta 2 prime and theta 3 prime, that gives you theta 3. So theta 2 prime plus theta 3 prime will give you theta 3. So theta 2 prime is 33.69 degrees plus the theta 3 prime 45 degrees. Therefore, theta 3 is what? What will be the theta 3? Just add 33.69 plus 45. The answer is 78.69 degrees. So that's the answer. Okay, that's the answer. And finally, what is the remaining problem? The n effector angle. So I will do it here. Insert a border. Let's insert a border here. Okay, that's it. Here. Our last problem is to determine the theta h. So where's the theta h? Just project or create a line or draw a line from the origin Where is that? It's the line from here to the n effector. So this is our theta h. So let me move this one first. Okay. Here is the theta h. This one. The n effector angle. Therefore, to get the theta h is simply apply inverse tangent y over x. Our y is 7, our x is 12. So that is inverse tangent 7 divided by 12. Therefore, our theta h is equal to 7 divided by 12 inverse tangent. We get 30.26 degrees. That's it. This is the solution for the inverse kinematic problem of a three-link manipulator. So this is the solution. Let me save this one. Okay, and I will stop recording. That's it. Okay.